enough points. So what's my rule? How many points do I want? At least 3 on both the parent function and the final graph. So what is my parent function here? Okay, so 0 squared is 0. 1 squared is 1. 2 squared is 4. -1, 1, -2, 4. So you can certainly do more than 3. That's the minimum. Okay, so tell me, what are the transformations here? Okay, so when you do stretching and shrinking, it's like multiplying your y's by 2. So this is at 0. 0 times 2 is still 0. And then we go right 5. Okay, this is at 1. 1 times 2 is 2. And then we go right 5. Okay, this one is at 4. If you take it times 2, you're at 8. And then right 5. Okay, this was a y value of 1. Times 2 is 2. Right 5. Y value of 4 times 2 takes it to y value of 8 and right 5. So you can see our graph kind of got skinnier as we did that. Is that okay with everyone? All right, let's look at number 2. So inside is x and it does the opposite. So what will that 3 do? So inside is horizontal, does the opposite, so it's a horizontal shrink. And then the plus 4 will take it up. Okay, so if you are going to plot the parent function, what is our parent function? So 0, 0, 1, 1, 2, 2, -1, 1, -2, 2. If you struggle with the stretching and shrinking, I told you you can write out ordered pairs. You certainly don't have to, but it could help. Since we're going to end up dividing by 3, I'm going to do some different points here just because my graph's kind of small and I want you to be able to see. Would you guys agree that 3, 3, and -3, 3 would be points on this graph? Okay. So what we're doing to our x's is the opposite of what this says. So that says times 3, so we're going to divide the x by 3. So that would still be 0, 0. This would be 1, 3, and -1, 3. And then what do I have to do to each of those? Up 4. So I can start my 0, 0, and take that up 4. Okay, 1, 1 is going to turn into 1, 3, and then up 4. Okay, so my -3, 3 turned into -1, 3 is the point on this graph. And then up 4. So we get the same shape, just a really skinny graph that's been moved up. Is that one okay? Let's look at this one. So parent function is what? Cube root of 0 is 0. Cube root of 1 is 1. Cube root of 8 is 2. Negative 1, negative 1, negative 8, negative 2. Are you guys all okay with how to get the parent functions? What does the negative on the outside do? And the plus 3? Alright, so if I take 0, 0 and I flip it, it doesn't go anywhere. And then left 3. If I take 1, 1 and flip it, it goes to 1, negative 1. Left 3. If I take 8, 2 and flip it, it goes to 8, negative 2. Left 3. Okay, if I take negative 1, negative 1 and flip it, goes up here. Left 3. And negative 8, negative 2, flip it. Left 3 kind of takes it off my graph here. What would be the domain and range of that graph? Good. If I asked you like increasing, decreasing, constant, where's that? What's that one doing? Decreasing the entire time. Negative infinity, constant. Alright, why don't you guys take a minute and try a couple? So I'll just give you a few minutes. If you want to work with someone, you can. Do as many as you can get. Alright, let's see how we did. So, number 4, we had the parent function should look like this. What does the negative on the x do? What does the minus 5 do? Alright, so 0, 0, if you flip it, it doesn't go anywhere. Down 5. 1, 1, if you flip it, goes to 1, negative 1. And then down 5. Alright, 4, 2 will go to 4, negative, whoops. I'm flipping over my x, aren't I? I wrote down y and then I flipped over my x. Let's try that again. 1, 1. If I flip it over the y, goes to negative 1, 1. And then go down 5. Alright. 4, 2 would go to negative 4, 2. And then down 5. So we get the same graph. That looks more like this. What would be the domain of that one? I didn't ask for it, but I could.
Negative infinity 0 and 0 is
Just the negative infinity 0. I would do just the final graph for the domain. What would be the range of that final graph? Good. Is that one okay? I think several of you made the same mistake I started to make, flipping it over the x.
I messed it up 4 times.
Yeah. Okay, number 5, parent function is x cubed. The minus 4 would take it right 4. The 1/2 is a vertical shrink. Okay, if you need to write out points, you certainly can. You do not have to. So these are the points I graphed. Are you changing the x or the y on these? Y. Outside is y, and it does what it said. It multiplied by 1/2, so it's like taking those y's times 1/2. I know a lot of you are doing this step in your head, which is great. I don't mind a bit, but if you are struggling with the stretching and shrinking, take a second to write out these ordered pairs. So 0, 0 would stay here, but then we have to take it right 4. 1, 1 would go to 1, 1/2, then right 4. 2, 8 would go to 2, 4, then right 4. -1, -1 would go to -1, -1/2, then right 4. -2, -8 would go to -2, -4, then right 4. So we get a slightly fatter looking graph. Shifted up. Number 6. Parent function is x squared. The +2 would move it up 2. What's the 1/3 do? If you need to, you can write points. Are we changing x or y? X, and does the opposite of what it said. So it said multiply by 1/3, so we can multiply by 3. And this would give us the points for the stretching purposes, and then we have to move them up 2. So 0, 0 stays, then up 2. 1, 1 would go to 3, 1. And then up 2. -1, 1 would go to -3, 1. Then up 2. So we're getting a fatter graph over here. Any questions on that? Last couple. So number 7, these should be a little bit easier because there's no stretching or shrinking. What's the negative do? What's the -1 do? And the +3. So 0, 0, if I flip it, doesn't move. Right 1, up 3. 1, 1 goes to 1, -1, right 1, up 3. -1, 1, if I flip it, goes to -1, -1, right 1, up 3. And you could certainly do more points if you wanted. Last one. So the cube root. What's the transformation on this one?
Left 2, down 4.
So each one left and right. Are we okay with all of this? Let's go to the back of this handout. we're still doing transformations, but the difference is I didn't give you the equation of the parent function. I just gave you a picture of what the graph looks like. And so we have to apply our transformations for those. This is common on like ACT because they're testing to see do you really know your transformations when you can't just plug it into a graphing calculator to get the graph. So they like to do things like this. All right, so on this one, this -2 is on the outside. So it's essentially anything on the outside is affecting y. And it does what it says. It's like taking all of your y values and multiplying them by -2. Because we have to flip them and stretch them. So we just take some points on our graph. So this one has a y value of 4. If you take that times -2, it would become -8. Here my y value is 0. 0 times anything is still 0. This one has a y value of 3. 3 times -2 is -6. 3, 0 would stay. Here my y is -2. -2 times -3, +6. This is 0, so it stays. So if we draw our graph now, just connecting our dots, if you can draw straight lines. I do better when I'm not on this.
Wait, wouldn't that be +4? That one is.
Yeah, why did I multiply by -3?
I think because the last one we had was at.
Is that why I said it? Yeah, sorry. -2 times 2 is -4. I think I said times -3. Alright, so we get this.
Still click on yourself.
We can see that it's flipped and kind of stretched. It got taller. You guys understand how I got that one? So number 10, what would I do with each of these points?
Write 3 out too.
Okay, so you're taking nice points on your graph and then just move each of those right 3 up 2. So shape didn't change, just the placement. Is that good? This one, what are we going to be doing to our graph?
Flip over the y-axis.
So take some nice points. So if I flip it over the y, it's changing the sign on the x. So this point will go to +10, and then we go down 4. Watch it. So we have -7, 0, watch it. If we flip it, it goes here, down. So we flip, and then down 4. Last one. What's it going to do?
Left one
Left one
up, window.
down.
I read the
Opposite
minus as a
portions.
plus.
We'll be looking graph. So take each point left and down. It's a very bad drawing. Hopefully yours is slightly better. Alright, we understand what we're doing in all this. Last thing I want to do, we did some of these yesterday, where I just want to try to come up with the new point. So take a second and try these on your own before we look at them. You can draw a picture if you want, you do not have to, you can just think about what each of these things is doing to your point. So we're at -2, 3. Figure out what the new point would be for each of those. So you can think of it a couple different ways. You can think about what your transformation does. You can also just kind of remember what I've been telling you over and over again. Inside is X, does the opposite. Outside is Y, does what it says. So inside is X, it does the opposite. So what's it going to do to my X? We're basically going to be moving this to the right 2. So the opposite of subtracting 2 is like adding 2 to your X. So you should get 0.03. This one outside is Y. So it's going to take my 3 and make it a negative. Or you could think if I reflect this over the x-axis, what's the point? Outside, Y does what it says. So that means you're going to take your Y value times 5. So my Y is 3 times 5 is 15. Inside X does the opposite. So it's going to change my X. What's the opposite of multiplying by 3? So it would be a -2/3. Outside, Y does what it says. So it's going to take my Y value times 1/4. Outside, Y does what it says. So it takes my Y value and adds 6. Inside, X does the opposite. So the opposite of multiplying by 3/4 would be multiplying by 4/3. So you get -8/3. Any questions on those? So then I have a handout for you. Tomorrow's quiz will be all of this stuff. You might also look back over symmetry, even and odd. That will be on there. If we have some questions tomorrow first thing, we can answer those before the quiz. Do you guys have questions on anything? Oh, I didn't do the last one, did I? Sorry, mine got cut off onto another page and I kind of forgot about it. The very last question. So that's taking your X and changing the sign so it should be a +2.